In class, we looked at a table of exponents and we looked for patterns and we figured out how to deal with negative exponents. We learned that negative exponents have nothing to do with negative numbers, that negative exponents have to do with reciprocals. So to deal with a negative exponent, you take the reciprocal of the positive power. Okay, so 7 to the negative 2, the way we handle this is we do 1 over 7 squared. That 1 over is a reciprocal. That means to flip it, and we take the positive power. So 1 over 7 squared, this would be 1 over 49. X to the negative 5 would be 1 over. That's what we do when we take a reciprocal, and we make it x to the positive 5. Okay, so negative exponents most often have to do with fractions. They will often turn into fractions, and often the numerator will be 1. So this is how we will fix negative exponents most of the time. Down here we see that we have this 1 over, and they want me to give the negative exponent. They want me to give sort of the original problem. This is the answer. What was the original problem? So 1 over 8 to the positive 3 had to start as 8 to the negative 3, right? That's how this would fix if we were fixing the negative exponent. 1 over y to the positive 7, the original problem would have been y to the negative 7. Now the math rule is that an expression is not simplified if there are negative exponents. Okay, so you always want to fix the negative exponents, but if they ask you to go backwards, then you know how to do it. So often in math, we learn a rule and we're like, okay, that was an easy rule. Now what? That there's got to be a trick, there's got to be something that's going to make it more complicated. And exponent rules are like that. The basic rules are very simple and not hard to deal with, but they're going to make the problems where we have to think a little more and maybe use something out of our bag of tricks to fix those problems. Okay, so let's talk about what a reciprocal means. A reciprocal, you probably learned that it is to flip a fraction, right? That's probably the way you learned it. So what happens if I take the reciprocal of 1 over 5, I get 5 over 1, or I would just write 5, right? But notice the 5 in the denominator moved to the numerator, the 1 in the numerator moved to the denominator. Well, what is the reciprocal of 5? Well, we would put that 5 over 1. We would flip it. We would get 1/5. Notice the 1 in the denominator moved to the numerator. The 5 in the numerator moved to the denominator. What is the reciprocal of 2/3? It's 3/2, right? That's sort of the easiest fraction to take a reciprocal of, is just sort of a normal proper fraction. We just flip it. But notice the 3 in the denominator move to the numerator. The 2 in the numerator move to the denominator. So what happens with negative exponents is they don't always start in the numerator. Sometimes they start in the denominator. Here you see a problem that has a negative exponent in the numerator and a negative exponent in the denominator. So what you do is you're taking the reciprocal. So if something's in the denominator, it's going to move to the numerator. If something's in the numerator, it's going to move to the denominator if the exponent's negative. So here I have 1 over x to the negative 3. Well, this negative 3, I need to take the reciprocal of that. So it's in the bottom. It's going to move to the top, and it's going to become x to the positive 3, right? Now that's over 1, but we don't typically write that over 1. We just write x to the positive 3. So the negative exponent, it was in the denominator, it moved to the numerator. The next one is y to the negative 4th over z to the negative 2. So what happens is you want to write a fraction bar, and you want to look just for your negative exponent. So here I have a y to the negative 4. It needs to change location. It's going to jump the fraction bar. It's going to go to the bottom, and the exponent is going to become positive. So y to the negative 4 in the numerator became y to the positive 4 in the denominator. I look at the bottom. Z to the negative 2, that's a negative exponent, which means it's in the wrong spot. So I'm going to move it from the bottom to the top, and I'm going to make the exponent positive. When you change location, when you go across the fraction bar, the exponent changes signs. So next, I have x cubed over y to the negative 7. So if I have negative exponents, I have things I can fix. Okay, so I'm going to draw my fraction bar, and you need to look at each exponent and see if it needs to be fixed, to see if it is a negative exponent and needs to be positive. So I see x cubed in the numerator. It's already a positive exponent. It is happy right where it is, so it's going to stay as x to the positive 3. I look in the bottom, this y to the negative 7 is not happy. It's negative. It needs to be fixed. So it's going to go to the numerator, and it's going to become y to the 7th. Well, what's left down here? If everything moved to the top, there's a 1 in the denominator. So this just becomes x cubed y to the 7th. So notice positive exponents stay where they are. Negative exponents need to go to the other side of the fraction bar and become positive. You have heard the saying about the grass is always greener on the other side, right? The grass is greener on the other side, meaning something looks better on the other side. Well, negative exponents are sad. They are not happy, and they think the grass is greener on the other side of the fraction bar. So a negative exponent will always go to the other side of the fraction bar and all of a sudden become happy. It'll be positive. Let's look at one more. C to the negative 5th over D to the 4th. Remember, the only ones that need fixing are negative ones because they are unhappy and they think the grass is greener on the other side. So C to the negative 5th is not happy. It's negative. So it's going to go to the other side, and it's going to become C to the positive 5. When it goes to the other side, it's happy. It's positive. Then I look at the D to the 4th. It's already happy. It's a positive exponent. So it's going to stay D to the 4th, and it's going to stay right where it is. Now, I can't have a blank numerator. What do you think goes in this numerator? If everything goes away from the numerator or denominator, it becomes a 1. And this, we have to leave this way because you can't have a blank numerator, but you can leave a denominator empty, right? You don't have to write over 1. But if all that's left in the numerator is 1, you have to write it. Okay? So now you have seen how to deal with negative exponents.